Good morning, guys. Welcome back. I hope you had a great Semana Santa. In order to kick off class again, we're going to begin with section 6.4, which is partial fractions. It is a very abstract operation. Pretty much you're going to be using this a lot in calculus. So it's a process that will help you in calculus, finding the area under the curve and such. So we're going to see it this year, and we might not be able to apply it heavily this year, but it's going to definitely help you next year. So let's go ahead and introduce it. These problems are somewhat long and tricky initially. Once you practice a lot, they're quite simple. So today, we're only going to do example 1. This entire week is going to be 6.4. After that, we're going to jump into vectors next week, starting Monday. So today, we're going to focus on 6.4, example 1. Now they're telling me, please express this as the sum of two simpler fractions. This is example 1. Express this as the sum of two simpler expressions or fractions. Now, pretty much, the denominator is going to be very easy to find for these fractions because all you have to do is factor this denominator, and that's going to give you the new denominators. The difficult part is finding the numerators. So in order to complete this process, you need to know factoring and also solving matrices, either using George and Gauss elimination, we already saw that, or Kramer's rule. We're going to do both today, just in case. So what you do is, step 1, you always write this as the sum of two fractions. You're always going to begin like that. The sum of two fractions. And what I have to do is find the numerators and find the denominators. So once I write this as the sum of two simpler fractions, you're going to factor the denominator. Today, you can use all the factoring patterns that you know: greatest common factor, difference of squares, standard form, perfect trinomial, grouping, and decomposition. Today we're going to give a small review of decomposition just in case, because it is in one of the guiding practices. But this one does not require decomposition. It's just standard form. Two numbers that multiplied give you this, the constant, and added give you this term. And of course, that would be x minus 5, x plus 4. When you multiply these two, you get negative 20. When you add these two, you get negative 1. Now, even though when we factor, we're actually multiplying these two factors, or it's a product, here we're going to write each one under a different fraction. So these are going to be your actual numerators. So even though here I'm multiplying, here I am adding. If you do this properly, the order doesn't matter, because remember, 2 plus 3 is the same thing as 3 plus 2. Order does not matter if you follow the proper processes. So currently, all I've done is factor the new denominator, factor the original denominator, and put the factors as my new denominators. Now the next step is quite simple. You're always going to write A and B, capital A, capital B. That's simple, always. If there are more factors, which we will see on Thursday, C, D, E, and F. You just write as many letters as there are factors. So right now, I have this. Now the next step, I'm going to explain what's happening, and even though it sounds very confusing during the explanation, what you actually have to do is quite simple. Now, all you have to do here is, let's turn this into factored form so we can see it easier. Again, this is the exact same as the expression before what I already had. Now, what you do here is multiply everything by this so we can isolate x plus 13. So in theory, I multiply a times this and then divide, and I see what I'm left with. And I multiply b times this and then divide to see what I'm left with. But in practice, it is very simple. All you have to do is multiply a times this term and b times this term. Again, let's just show you so you can see what's happening. If I multiply a by these terms, and then I divide by the numerator that I have here. After you simplify, you're left with this letter and this term. Likewise with b, it's going to be identical. So in practice, all you have to do is multiply these two and multiply these two in order to isolate this and end up with this. X plus 4, this times this, plus b x minus 5. So all I did was isolate x plus 13 and got rid of that. Now what am I going to do? Distribute my a inside this parentheses and distribute my b inside this parentheses. So again, I'll have x plus 13 equals ax plus 4a, and here I'm going to have bx minus 5b. After you distribute your values, we're going to start grouping. Everything that has an x squared, you're going to put it on one side. Everything that has an x, you're going to put it somewhere else. Everything that has a number, you're going to put it at the end. And I recommend you put it in decreasing orders. So here I have x's and no x's, or constants. So let's first of all put everything that has an x together. I have ax and I have bx together. They both have x's. And now I'm going to have my non-x values. 4a minus 5b. Now all you have to do, we're gonna work up here now. All you have to do, let me actually rewrite it up here so we can start working downward. Again, I am just rewriting my expression. Nothing new is happening. It's gonna be easier to work. Now, all we do now is we're gonna put parentheses so we can group. Again, these two have an x in common, a plus b. These have nothing in common, so you're just gonna write parentheses for a minus 5b. Nothing in common, these have an x in common. Now, we're almost done actually. Now, we're gonna create a matrix with these values that's going to give us our x value and our constant value. How do we do this? We just do an augmented matrix. Since this is going to be x, again, this is going to be my first line. What is this number and this number? 1 and 1. And that is going to be equal to my x value, which is 1. Again, these are my x values. This is my x line, which is the first. Remember, usually it's x, y, z, etc., etc. So the x values, which is 1 and 1, will be equal to 1. Now I'm going to use my y line. 4 and negative 5 is equal to 13. That is your augmented matrix. 1 plus 1 is going to be equal to the 1 part. 4 minus 5 is going to be equal to the negative 13 part. When you find your solutions, this will be your A, because again, it's the first one, X, and that's going to be your A. And the second one is going to be your B. Now let's actually solve each one. We can use Gauss-Jordan elimination or Cramer's rule. Let's use Gauss-Jordan first, because I think it's way easier. Let me rewrite this in a smaller matrix and let's get the job done. So again, I have 1, 1 equals 1, 4, 5, negative 5 equals 13. That is my augmented matrix. And again, the first one will give me the A value, which is the first term. The second term will give me the B value, which is the constant term. So in order to, we're going to do both Gaussian and Cramer's, and you'll see you'll get the exact same results. So to use Gaussian, I want to get rid of this 4. So I multiply the first one by 4, and I add it to the bottom one. 4. I have to actually change it to, I have to multiply it by -4. I have to multiply everything by -4. Now when I add this to the bottom line, -4 plus 4, I'm going to get a 0. -4 minus 5, I'm going to get -9. And -4 plus 13, +9. So after I multiply the first line by -4 and add it down here, I'm going to switch it for the new result. 0, -9, and 9. Now, in order to simplify this, I'm going to divide the second line by 9, because I can do it. It's an equality. 0 divided by 9, 0. -9 divided by 9, -1. 9 divided by 9 is 1. So I got rid of this value. Now remember, in order to solve, all I have to do is get rid of this value right here. So when I add the second line to the first line, this value will disappear. And let's see, what is 0 plus 1? 1. -1 plus 1 is 0. 1 plus 1 is 2. This becomes my new first line. And now I can clearly see the A value. A is equal to 2. And B is equal to 1. -1, pardon. One thing. Since this is a -1 and it has to be +1, I multiply this row by -1, turns this number positive and this number negative. And the result for B is -1. So to finish, all you have to do is, once you have your A and B values, you're going to rewrite your expression. The original expression was this. That was the original expression, and that was equal to A, x minus 5, B, x plus 4. But now I know that my A is 2, and my B is -1. This is your answer. You returned a rational expression into the sum of two simpler fractional expressions. That is the answer. Now let's do the exact same matrix, only we're going to use Cramer's rule. And you'll see that I'm going to get the exact same result. Now again, the matrix was 1, 1, -4, 5. And that is equal to, and this is important, 1 and 13. Now, when we're doing Cramer's rule, let's find the determinant. 1 times 5 is 5, minus -4 times 1, -4. My determinant is 5 plus 4, or 9. That's my determinant, 9. Now, in order to find, remember, and in Cramer's, this would be A and this would be B. We use the columns. I'm going to substitute the first column for these values. So I would have 1, 13, 1, and 5. I substituted, again, the first column for these values. And, this is -5, pero lo puse al revés. Era así. Perdón. That's how it's supposed to be. -5 and +4. -5 here. So when I substitute the first column for the values that are equal to, for the answer, I'm going to find the new determinant and divide it by the original determinant. 1 times -5 is -5 minus 13 times 1, 13. -5 minus 13 is -18. -9. The determinant is -9, sorry. -9. 1 times -5, -5 minus 4 times 1, 4, -9. So when I divide my determinant, my new determinant, substituting the column with the original determinant, I get that my A value is 2. the same thing we got with Gaussian-Jordan elimination. Now let's substitute the second line. Now I'm going to put the first column as is, and I'm going to substitute my second column with the equal values. I'm going to find the new determinant and then divide by -9. So 1 times 13 is 13, minus 4 times 1, 4. 13 minus 4 is 9. Divided by the original determinant, I get an answer of -1. So A equals 2, B equals -1. As you can see, we got the exact same answer with both Gaussian elimination and the Cramer's rule, because it's supposed to be the same answer. When you're working on these, you do not have to do both. You choose the method that you rather work with, and you just go ahead and do it. My recommendation, 3x3 matrix. Personally, I would do elimination, Gaussian-Jordan elimination. 2x2 matrix. If the numbers are small, elimination. If the numbers are larger, Cramer's rule. But it's the same thing, just whatever you're more comfortable with. As you can see, I got the exact same results, and then I rewrite my fractions in the exact same way. X minus 5 plus -1, x plus 4. That is the exact same problem with the same answer. Now I'm going to do guided practice 1A, and I'm going to begin working guided practice 1B, but you're supposed to finish that guided practice together with the homework. So let's work with the guiding practice 1A. I'm told 2x plus 5 divided by x squared minus x plus 2. Minus 2, sorry. Okay, ahí está. Now, step 1. I rewrite it as a sum of two fractions. First numerator, always A. Second numerator, always B. I'm going to factor this. When you factor this, you're going to get x minus 1, x, let's see, multiplied, I get this, added, I get this. So it would be x minus 2, x plus 1. Multiply these two, -2, add these two, -1. So the first one I'm going to put is x minus 2. Second one I'm going to put is x plus 1. Okay. Now, in order to isolate the denominator here, I erase it. And all I do, again, remember, multiply A times this and multiply B times this. So I'm going to end up with 2x plus 5 equals A times x plus 1 plus B times x minus 2. I'm going to distribute my values within the parentheses. 2x plus 5 equals ax plus A plus bx minus 2b. Distributed properly. Next step, I'm going to put together the values that have the same degrees. There are no x squares, but I do have ax plus bx, and then I have plus a minus 2b. I'm going to rewrite this as parentheses. 2x plus 5 equals common factor. And here I have no common factor. So I'm going to rewrite this up top to start working. So I have, actually I'm just going to write the matrix. Remember, the value of the x is going to give me this, and the value of the constants is going to be equal to this. So when I write a and b, 1 and 1 in my matrix, it's going to be equal to 2. And then I write these numbers, 1 and -2, that's going to be equal to 5. That's my augmented matrix. Let's do this via elimination, because it is very simple. I'm going to multiply the bottom one by -1, and I get this number. When I multiply the bottom row by -1, I get this row. And when I'm sorry. Perdón. I'm going to multiply the top row. It's actually the same. But if I'm going to add this here, I like to manipulate this one. I'm going to multiply the top row by -1. then I'm going to add that to this row. When I add this and this, I get 0. When I add this and this, I get -3. When I add this and this, I get +3. Currently, that is my new matrix. Now I divide this row by 3 to end up with 1 here and 1 here. Next, I'm going to multiply that same row by -1 just so I can switch these signs and end up with a 1 here. Now I know that my b value is -1. I know it. You can do substitution, etc., etc. I just like to finish with elimination. Now I'm going to multiply this row by -1, so I get these values, 0, -1, +1. Now I'm going to add this row to the top row in order to simplify. 0 plus 1 is 1, -1 plus 1 is 0, 1 plus 2 is 3. So now I know that my b value is -1 and my a value is +3. All I have to do is rewrite the fractions. I believe I put x plus 2, x minus 1. I believe that's the order I put them in. If not, well, I'm sorry, just flip them. But again, I erased, I really don't remember. My a is 3 and my b is -1. That would be the answer. Using factoring and matrices to pretty much decompose a rational expression into two simpler fractions. That's example 1. Examples 2, 3, and 4 are pretty much the exact same process, only with slight variations. That's why today I only want to focus on example 1. We're going to practice, and tomorrow we're going to do example 2. Now, in order, I'm going to begin going over guided practice 1B, just to help you out with the decomposition part. Note that they give me this, and then I have 2x squared minus 5x minus 3. Now, remember, decomposition is pretty much like a more complex form of grouping. Since this number is a non-1 number, and I can't simplify it any other way, I have to do decomposition. Now, decomposition works very similar to standard fraction factoring. The difference is you're going to find the number that when you multiply, you get the product of these two numbers. So what is 2 minus 3? -6. When I multiply those two numbers, I have to end up with -6, which is the multiplication of these two numbers. And those exact same two numbers, when I add them, I get -5. The numbers are -6 and +1. When I multiply these two numbers, I get -6. When I add these two numbers, I get -5. So again, to repeat, because decomposition is tricky, you multiply the first and the last numbers. That gives you -6. Now you're going to find two numbers that when you multiply, you get this number. And when you add those two, you get the middle number. It's this. So how do I continue working? I'm going to write the first number as is, identically. But now that's why it's called decomposition. I'm going to decompose this number into these two numbers. And I have to remember to add the x. Now note, what happens when you add -6x plus x? Do I not end up with -5x? So all you're doing is breaking down the middle into two parts so that now you can work with those two parts. But it's the exact same value. Let's give you another example of decomposition. Say I have 3x squared plus 6x plus 4. You could break this down into 3x plus 3x. Because again, when you add those two, you get 6x. All you're doing is decomposing a single value into two. So now you can do grouping. Let's see what happens now. Remember grouping, I take two numbers and I do greatest common factor. What do I have in common here? I have the 2 and the x. And inside, after you divide by the common factor, I'll be left with x minus 3. Again, you take the first two and you're going to do greatest common factor. You're going to take the second two and you're going to do greatest common factor. Now the second two, they have anything in common. They don't have anything in common. So outside, I have a 1. You have to remember that 1 or it's going to be wrong. So you have 1x minus 3. Okay. Now remember, when you're doing grouping, after you decompose, it's a normal grouping operation. When you're going to do grouping, the values within the parentheses have to be the same. So you know you're doing a good job. So that's going to break down into, this is going to be one factor, x minus 3. And what's on the outside, including the 1, will be the other factor, 2x plus 1. Now that you have the factors decomposed, now you can actually begin the exact same process using these values. Remember, order doesn't matter if you put this here or this here. At the end, when you do the matrix, it's going to give you the right answer. Now you just do this as you do a normal matrix and you get the job done. Multiply this by this by this, and then do your matrix. If you have any problems, let me know. So right now, I would like you, for homework, to finish the guided practice, 1B, and also do exercises 1 through 6. That's going to be the homework. If you have questions, let me know via chat. Remember, it's long. There are multiple processes involved, but you've done each one individually very well, so I don't think you should have a problem here. If you do have problems, let me know. It's the exact same process every single time. Factor denominator, cross multiply, distribute your parentheses, group your values, augmented matrix, find solutions, done. This will help you next year a lot. And you should feel very, very honored. You're the first class I have ever taught this to, because we're going so fast with these sections, with this method, that we will be able to finish most of the book. So again, not that difficult. Get the job done. Remember to post your homework before 10. And there's no news on me giving tests yet, so the homework is going to be weighted heavily. Do not miss a single homework, please. Have a great day. Nice to be back. Hope everybody's healthy. See you soon.